That comment seems not correct. Pretty sure that create this should create it. It's a verbal function. Texture isn't even doing anything. Yeah, it seems to be creating it. Well, of course, I would say, but so the comment was wrong. This is just creating it. Except when it is a texture, in that case it is already created, so it doesn't do anything. Oh, that's why the comment was there. If not already created, it's for the texture. Oopsies, okay, yeah. Well, that wasn't clear. I'm gonna change it to EG. Currently, texture's the only one what might be more in the future. So IE means in other words, and EG betekent means for example. think I'm going to move this to the top. I have all the creation behind me. Can just do that here first. Right, that's definitely correct. If it was already created before, then we did not add this thing to the required shader resources list. So everything in here has not been here before. Assuming that we are not going to return from this function until calling set created. But it's kind of dual thing here. The created flag, set created, is sets a boolean. Does really means really two things, namely that created was called, but also that it was bound to a descriptor set. So this whole block here. Now there's two possibilities. If it was already created and was also already bound, I'm going to call it binding instead of updating. I don't know. That's updating is a bit. Yeah, maybe updating is not that bad actually, because it's not a one-on-one relationship. You can bind, still using bind, the same shader resource to multiple descriptor sets. And of course a descriptor set can be bound to multiple shader resources. So yeah, anyway, we must make sure that set created is called also on each of these things here, but later. And there is definitely a problem with that. So might have to change this. I don't know how yet, however. Okay, here we get a list of descriptor set layout handles. And that seems correct. And they match the layouts that I want for each of the descriptor sets. That must be stored in this vector here. So another thing that this function is doing, initialize this vector. Let's see if that is already mentioned in the comments. Apparently not. It is true if this task slash thread succeeded. I'm just going to call it a task. If this task succeeded in creating all shader resources, what task? It is true if the pipeline factory task, like this, pipeline factory task succeeded in creating all shader resources. Needed by the current pipeline, current being the pipeline that's currently being created. And false if one or more other tasks are creating one or more of those shader resources. At this moment. Upon successful return, it means it returned true, right? That vector is also filled. Was initialized. With handles to the descriptor sets. Same thing, right? Used or needed. Needed by the current pipeline. So what else does this function need to do? It needs to call update descriptor set. Trying to use the word update anyway, otherwise you get confusion. Must be consistent. So that is updating of descriptor sets. Then those descriptor sets are additionally updated Yeah, then what is the word? I think binding is the right word though. And this sounds like we first have descriptor sets and then we also update them, but it's more like additionally those descriptor sets are updated to bind to the respective shader resources. The descriptor set are created as needed. If there already exists a descriptor set that is bound to the same shader resources that we need, we just reuse that descriptor set. I think that's the correct objective here. Then what else are we going to do here? I think that's about it. So that requires us to find if the descriptor set needs to be allocated. So here we are allocating descriptor sets, but not all of them need to be allocated, perhaps. It is possible that yeah, one or more already exist. It's just very hard to find out if that is the case. I think I need an overview of all the possibilities. Let's say yeah, let's say we have shader resources. I'm gonna call them, they have a type, so let's use a character to designate the type, although type is more complex than just texture and uniform buffer. Maybe I need to refresh my memory on that, what it is exactly. Okay, this. I'm now under the table. Okay, there we are again. This component should prevent my keyboard from dropping off. Or I should just put a longer iron rod in it, I think. Let's hope this works. Yeah, so we have shader resources. For example, well, that doesn't really matter. So I'm going to use texture 1 and 2, and uniform buffer 1 and uniform buffer 2. And I'm afraid that's not even enough. Let's use maybe a list at the same time. Let's say we use descriptor sets that bind two shader resources. So I am going to have descriptor sets that bind, for example, T1 and U1. And I'm going to have one that binds T1 and U2. And I'm going to have one that binds well, T1 and T2, I guess. Or is that nonsensical? Or when you have two textures? No, not entirely nonsensical, I guess. Because then we might also have T2, T1, which is different. Don't ask me if that is possible. I think it's possible. Because these two are the same type. I think at some point they're indistinguishable and they will be randomly ordered. While texture is always, well, second. So I should do U1, T1. Textures come after uniform buffers. But here the order is unknown. And then the same thing I can have for U1 and U2 and U2, U1. Yeah, well, I don't want to add a U3 or anything. So I think I have all the possible combinations now. Sort of. Except, of course, U1, U1, T2. Well, let's add all of them, I guess. U1, T2, and we have U2, T1. Yeah, okay, so since I have only two textures and two uniform buffers here, you have exactly two possibilities for having two uniform buffers, and we have two possibilities for having two textures. And if I have a uniform buffer, one uniform buffer and one texture, the texture is always in the last place. So we get four possibilities. One or two at the first place and one or two at the second place. Oh, that's 8 in total. Yeah, what else do we have? We have, so these are the descriptor sets that are already updated to, well, be bound to the shader resources. But they also have a layout. So we have a descriptor set layout. And I guess that comes before the actual descriptor sets. And the layouts that we have is u, u. U, t. And t, t. There's 3 different layouts, right? What else do we have? We have the descriptor set hints, set index hints, set indexes, bindings, keys. I think that the key is simply this thing. The key is a unique number per shader resource. So each of these things has a key, and I could mention the keys here, but they are just, let's say, 1, 2, 3, 4, or something like that. And I can already distinguish them the way they are called now. Okay, and then I have set index hint. That is more vague. Set index hint has to do with pipeline factory and or with pipeline. But now, if a pipeline factory creates multiple pipelines, then it is also possible that each pipeline factory would create a single pipeline, and I just have a lot of pipeline factories. So that we try to do everything in parallel. And that is then the most complex case. So let's concentrate on that. Then they can all have different set index hints. Now I'm wondering if they can have different set index hints if they belong to the same pipeline factory. I think theoretically everything is possible, so let's just assume. Maybe it kind of makes sense to see how many different pipelines I can make from this. And I will pretend that each pipeline is a different factory. Let's just start with the pipeline layouts. Pipeline layout. What we can have is Well, let's use everything. So we want to bind in total 4 shader resources to every pipeline. So I'm going to need 2 descriptor sets, and shall I use a different bracket so it's less confusing? I'm gonna use this one. So let's start with this one. That is 1 descriptor set, and then we have only U2 T2 is possible. Although it could be the other way around, because then this is a binding number 0 and this is binding number, no, it's not true, it's sets. Oops, this is set number 0 and this is set number 1, and they could have been swapped. So we want to make a listing of all possible pipelines, pipeline layouts. Oh wait. I was going to do layouts, so that would be, this is possible, but then the layout would be exist of layouts. So we can have UT twice, and then of course swapping doesn't make much sense. Or you can have, well, if we have UT here, we need a UT here, so let's pick one of the others. We have 2 uniform buffers here, and then we need 2 textures here. And finally, we can have 2 textures first, and then 2 uniform buffers later. Or can we? Because also here is sorting happening. No, I'm not sure if that is being sorted like that. That is a good question. I think it is sorted. Yes, it is sorted. Let's say if we would create this thing, this is about layouts, right? Just the pipeline layout. Where am I creating pipeline layout? Let's find it. Create pipeline layout. Create pipeline layout. Okay. Talking about that part. So they are initially put in the order by set index hint. From whatever the set index hint is for that layout. Yeah, I don't think there's any ordering there. Okay, I'm gonna assume that there's no ordering there because it seems very, very likely. In other words, it is possible to have both UU and then TT or the other way around in terms of layout. I'm going to put them below each other, I think. So that gives rise to the following possibilities. The pipelines. We can simply have a 1 here, and a 1 here, and a 2 here, and a 2 here. Or we can have a 1 here and a 2 here. And then this must be a 1. Or we can have a 2 here. And let's say a 1 here, and then 2 here. So something like that. Yep. Is that the case? Do I have U1, T1? Yeah, that's one of those 4. We have all 4 possibilities. Then we have, of course, this layout here, which then exists of U1, U2. Or the other one. So that's this one. And then the T also has 2 possibilities. So also duplicate this, and then we add here T1, T2. Or T2, T1. And then we have this possibility, which is exactly the same as the one above it, but then swapped. So I'm just going to do okay, I can do that with VI. 1, 2, 3, 4. Okay, so I think these are the all possible pipelines then. And now any of those pipelines can be created in any order by any number of pipeline factories, theoretically. And then the question is, when do we need to create a new, allocate a new descriptor set. And I think we need to make a new descriptor set, the one's different. So the only descriptor sets that we want to end up with are these 8 handles. And if we would just bluntly allocate new descriptor sets every time I get here, the way it's doing it now, I would end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2 is 24. So it would be a threefold increase, possibly. Well, if you are this insane that you want to create every possible permutation of these things, but theoretically. Okay, so how do we find out if one of these things already exist, while the only thing we have is a list of this? Yeah, not easy. Suppose this is not correct. U2, that must be U1. The rest seems correct. Okay, so imagine we have created a random pipeline. Let's say this one. Nah, this one. Nah, that's the same one. What the hell? Hope I finally did it right now. I think so, yeah. They're all different now, right? Okay, so pick a random one. I wonder let's use this one. Let's say this was created. And now we want to create, let's say this one. Then all of the shader resources are already created. And what information do we have? Well, each shader resource is going to contain a reference to a set layout. At least that's code that I wrote yesterday. Each shader resource is going to set the set layout here, which is a reference, I hope. And a set layout exists of the following. exists of a vector of the scriptal set layout binding and set index int and the handle of the set layout. Okay, now since the handle is explicitly mentioned here and it's going to be unique, pretty sure of that. Or is it? Yes, it is. Or is it? No, not really. The set index is not very clear, I'm afraid. So could it be that I'm not going to allocate a new handle when the sorted bindings are the same? What I do is I work with a copy then of the other set layout, I guess. And then we work with a set binding map. And that maps the set index into the previous set index int that we already had. So a set layout plus set binding map would be the same anyway. What? So these are set layouts, right? What the hell? It's not even, I would say, complex enough. Just two uniform buffers and two textures. I don't get all the possibilities. For example, if this one matches, then the other one does too. Which is nonsensical. No, it's not entirely true because these two differ in binding number. So this one would match and that one doesn't. Nevertheless, Yeah, I'm missing my set index hints. I think I made an exhaustive list here of all the possibilities. That should be then U1 has 4 possibilities, U2 has 3, and then T1 has 2 possibilities left. So that would be 4 times 3 times 2. It's 24. I don't see 24 things here. Why not? Because if a U and a T are in the same pair, the T comes last. But for the rest, so I have U1 T1 and U1 T2. And then, yes. Or U1 U2. And 2 of those. Or U1 T2. Yeah, well, already had that. No. Yeah. Okay, and so instead of 24 we get these. How many other? 12. I think that we have to assume that this is the initial thing or the pipeline that we would create if we were the first. But things might change if we first create another pipeline, because I don't want to make duplicates. So, for example, let's say this pipeline is being created first. And I'm going to create U2 on here, this 1 second, handpicked. Then what happens? Well, then in the first case, this is set index hint is 0, and this is set index hint 1, and that's where they stay, because they are first. Why not pick whatever we hinted? Now, every unique. So, yeah, I can, let's say, these are layouts, but my set layouts, objects, they have a set index hint also in it. This does not make things very much simpler, I have to admit. That's a set. Set index hint. Yeah, well, I don't think there's... Rather I should put it here above here, but let me add it here as well, so we can see what happens indeed. Because the set index hint comes from the place where it is. So this is always 0 and then 1. Which means that this one becomes, there are twice as many set layouts as the descriptor set layout handles, basically. Which is kind of weird because we store one handle in the set layout. So what you really get is just a pick, depending on which one is first. Well, we know which is first, so let's say this one is first. That means that the UU is going to get set index 0, because this is on the left side here. So the set layouts then become this. And we create this one, T2, T1, so it's TT in number, in place number 1. And we are not creating another one yet, so this one doesn't exist yet. Might never exist because the second one also combines something like that. Well, pick a third after that, or maybe change the second one for another test. Okay, that's wrong. Again, this is of course UU. Yeah, so the first one here, that is set number 0, is UU, and the second one, or set number 1, is TT. So these must exist. And then another pipeline factory is trying to create this. And that works as follows. It says, well, now TT is at set index hint number 0. So we do get the other one. We do get this one. But I'm not storing them globally, and they are going to be, the TT is going to be found, and then we see that it is set index hint 1. So you're going to get a translation set binding map from set 1 to 0 and 0 to 1. So at the moment that we get here, we have found TT already, because this one was created. And now it is at 0, but it used to be at 1. So the set binding map then is going to be, while creating this, 0 becomes 1, and 1 becomes 0. While creating this one, we did have the identity map. 0 became 0 and 1 became 1. And now each of these, at the moment of creation, we put a reference to a set index, sorry, to a set layout in the shader resource. So also after this, we have that U2 points to yeah, the U2, U1 set layout, which, if you ask me, is this one. And the U1 also. It's in the same set layout, and the T1, so it's the T for T2 here, gets a reference to this one. And finally T1 is a reference also to the same thing. And now we get here. And now T1 has a set index hint of 0, but yeah, maybe I can just look up, maybe I can just translate that to 1 to begin with. Might be nonsensical though, not sure. That might actually work. But no, nah, not really. Only because they are in the same column here. I mean, this thing must be found wherever it is. And it could be anywhere. So now it's at index number 0, and then if I translate it to a 1, it corresponds to that one. Yeah, well, maybe. I don't know. textures. I had a feeling that I could not use the set index values. The only thing I can use is that they are the same. So I have T1 and T2 are in the same set here, both 0. And then based on that I can find back that they already exist, because both T1 and T2 have a reference to a set index with the same set index int. That's why I can use them. There's also a handle here, and then I can just use the handle from either. Yeah, well, I also have a binding number, I think. Maybe, I have to check those as well, because that's why I picked this one. The binding numbers are wrong. I mean, for the U2 and the U1, they are correct. U2 was first here as well. So the binding number of U2 is 0. The binding number of U1 is 1. But here, that for the texture case, they are swapped. So I'm guessing that the binding number is also ending up here in somehow. Or should have ended up. Yeah. I have to store the binding number as well, I think. So here we have the set layout stores this information. But I'm also going to store that the binding number is something. Let's use angle brackets for this whole thing. No. The binding number for U2 here is 0. Let's put this on a new line. Oops. The binding number is 1. And here we have T2 is at 0. And T1 is at 1. I don't think I should use the mapping here, really. So let's, if I do not use the mapping, then at least the set index hints are different to make that stand out, as it were. So if this one was the first one, we would have gotten T1. T1 is at set index number 0. Seriously? Yeah. And with layout T, T. And binding number 0. And T2 also set index number 0. T, binding number 1, and U2 is at set index number 1, layout U, binding number 0, and U1 is at set index hint number 1, layout U, and binding number 1. And then we must find that the U's correspond. So this block here is the same as this block, even though the set index hints are different. But they belong to the same set index. These two belong to the same set index, so they form a pair. And then we find that back here as well, under the same set index. And they match. While this is different. So we have a 0, 0 pair. And here we have a 1, 1 pair. But here T2 has a 0 and here T2 has a 1. So they do not match. In the other case they are in the same order, so they do match. Yeah, okay. How do I find it out? I guess I need to sort this information by, well, as a vector of these things without set index hints, but sorted by set index hint. Holy shit. Yeah, so... I need names for these things, so I can think about them and or code them rather. Thinking is not an option. This is signature maybe. There's something else that's bothering me. I have the feeling that I need to store all of them. Yeah, in the end we need to store all of them. Holy shit. That is a problem. Because this is what we want to do if it doesn't already exist. And this is what we want to do if it does not already exist, but from the viewpoint of the second pipeline factory, they didn't exist and they are created. So they are kind of a different beast. These already exist. So what's going to happen is that the U1 is not going to allocate anything new, but with the salt binding numbers for the textures we are, which means that which means that a different is definitely problematic. Definitely problematic. So I'm getting it's not just this is what you want, but let's say a third. We're going to create a third pipeline. At that moment, we have we put that here. We still have this list, of course. That's not working. Still have this list, but now also T2 is bound to T2 should be pointing to rather this thing here, because it's going to be created because the binding number was different. So that gives us a second handle, but that handle refers to the same thing as this one, which also gets another one. So that is T1, that's this one. However, you cannot use them like this, this one and this one. In this layout, TT means that the T1 and the T2 form a set. Literally, descriptor set. So I can put a TT also in front of this as a... And this TT is really binding the meaning T1 and T2. And I have to find back. I only have a T2 pointing to this, and then I can find back that the other one is T1, because T1 is the one that is also a texture. Although I probably don't even need it, but because it has in the first place of this list, I think I'm going to do that. It's just a vector with another index. So this is at index 0 of this vector of things here. Let's make clear that it is a vector. And then at the first place we have this, and here we have at the first place this. And therefore we combine this one with that one. We have two. But we also have this one combined with that one. And then automatically I think the whole set layout reference is going to be the same. So it's definitely going to be... Oh wait. Am I going to make a copy of the set layout? Oh yeah, different handle. The handle is also in there. Okay, so we have a reference to the set layout that says this plus a handle, and this is the same thing. It's the same handle. So twice the same reference. I might as well use the pointer then. Just compare the reference pointer. It's a canonical pointer, so we can do that. Yep, and the same thing here. These two have the same set layout object, or point to the same set layout object. Therefore they are the same. But it could be that there is also set index 1 here and there, of course, because they are the same thing. So we cannot look at the set index int, but you can look at the index of this vector here. This is 0 and this is 1. At the very least, I have enough information. I think if I also store the binding number in the shared resource. But it must be a whole list of things, not just a single reference. So I'm no longer going to store references. I'm going to store pointers to set layouts, and then paired with the binding number, and then all of that in a vector. I'm going to need a name for this thing. So it's a pair of a set layout with a binding number. Set layout binding, I guess. Really? Yeah. No. On just for declaration, so be enough. Set layout, which is defined in namespace vulkan descriptor as well. And then this is just a set layout const pointer, which is the set layout canonical pointer. And we have a binding number. Okay. Let's see if we can get away with a constructor that demands that everything is immediately initialized. And we're going to need access source. And I probably need a debug output. Always forget what a header I need to include for that. Something. De header voor print on printing. Thought it was CWDS debug O-stream operators. Let's have a look. Debug, maybe. Only using that here. But then again, I'll end here, but feels unlikely. Let's see if we can find it in debug here. Debug. Maybe this one? No. No, this is for VK, for vulkan objects, which do not have a print on, obviously. Well, I think really that it is all the way in CWDS. Nope. No, it's apparently this is more for printing STD types. Where is it? Don't tell me I put it in this print on. Thought that it was only the hook, the namespace hook. Yep, and I already have a descriptor in it. Oh, but that feels like utils. Oh, this utils. Okay, utils has also debug O-stream operators. Print on. Obviously it has that, right? It doesn't. Huh? What? No, you're going to be kidding me. It is not doing anything, this. It says error. Insanity. Where is this defined? There must be a has print on function somewhere. It is utils has print on, I guess. Which is included by debug.h. Yep, there it is. Well, this thing prints everything that has a print on. So I can either include utils has print on. See how often I am doing that. Not often. Can include debug vulkan print on, which also includes it. Did do it in textures. Oh, I'm not seeing the debug one now. Isn't that very weird? Okay, I give up. Let's say well, I'll just include utils print on .h, I guess. It has print on. No, not really. No, I need to get this inserter as well. So it is a vulkan. It is a vulkan thing because it is in this namespace. So I need debug print on, or I don't know anymore. What was it called? Vulkan print on. Finally, I have it. Okay, I think that's what it is. A class inside vulkan namespace needs debug vulkan print on. Now we still have to define it. So let's make a .cxx file. Set layout bounding .h. Yeah, and then I have something like print pointer. as in a certain namespace as well. Namespace is vkutils, and we need vkutils print pointer. Right, but that's that. Print can print it. Oops, forgot the sysing. Oh, it's still not happy with printing set layout. Why is that? I never included the header of set layout, if you ask me. We did forward declared, didn't I? That was it. So now our shader resources. Let's go to there, shader resources. What? What is inside shader builder? I think it's still shader resources. No, it's shader resource. So in base.h, I'm going to have instead of thought this thing had a set nog something. Set let, oh, it's not even storing anything yet. Right, so yeah, well, let us not sure I want to store an iterator. Might as well store a pointer. Don't want to iterate, I just want to point. So I mean, we are just going to pass our new set layout binding. Which is a pointer and an integer, so no moving is possible. Might as well copy it, it's not that large. This is in line. Let's pass it by value. Set layout binding. And then I'm going to add it to a list of set layout binding. Let's call it set layout binding. Add. It's not set, now it's add. Set layout binding. And then we have a set layout bindings list. bindings. I'm gonna call it list. I mean, I call everything a list. I seldom, no, let's say never use standard list, but I call my vectors list because that's what it is, humanly speaking. Okay, so set layout bindings list pushback. The set layout binding. Maybe I should use in-place back, but I don't think it makes any difference. In assembly-wise, I mean, after compilation. Yep, and then we need to define this thing. Set layout bindings list. So that's going to be a vector of set layout binding. Right, I want to give that thing a type using set layout bindings list container. Okay, that's dirty. I mean, a list is also a container. Do I really want to use this then? Nah, let's remove the list. I'm going to container is my standards vector. And then we use that here. And I just remove the list. Yep, and we add an accessor again for it. How do we do that? Well, I added an accessor. Do we have an accessor? I want to access that. Let's make that a const reference. Set layout bindings. Oops, what was this? M underscore this? No, not really. I think just like that. Set layout bindings. Well, in this case, because we are declaring a vector of that, I definitely need a header. Descriptor set layout binding. So much for avoiding including set layout.h in that header. Yeah, and now it doesn't compile anymore because I don't have a set layout binding anymore. Can I find that thing? Set layout. Yeah, just set. There's no binding yet there. So this becomes add set layout binding. And now we need to pass the set layout binding, which might as well pass that as a constructor, where the second argument is a binding number, probably that binding number. And the first, no, do I want to have a spaces here or not? I think I do. Set layout, well, there was an iterator. It's a dereference iterator. No, I want a pointer. I need a pointer to the thing. Well, or an iterator. I could maybe mean, yeah, well, what shall we do? Iterator, pointer, iterator, pointer, pointer. Well, this is then a descriptor set layout canonical pointer, right? It is a set layout canonical pointer without the descriptor in front of it. Yeah, okay, because it's called set layout. You gotta be wondering then why there is a descriptor here. This thing is really pointing to set layout classes. Oh, I changed that to be descriptor set layout when that is sorted. Yeah, I did that yesterday. Still dubious. That was because this thing is not always defined in namespace descriptor. So we have sorted descriptor set layouts container because it is not inside namespace descriptor. And now we are also not in the namespace descriptor. So that's a good thing that we call it descriptor set layouts pointer, I guess. But then this is a iterator to a descriptor colon set layout. I don't know, let's rename it to something long, just because. Script set layout canonical pointer. Oops. Yeah, that was not what I wanted. Substitute this thing back to what it was. Not sure if this is working now. I'm doing colon S. Should not. Wait a minute. This still works. That doesn't make anything easier. Now I have descriptor set layout. Canonical pointer is something in descriptor set layouts canonical pointer. Yeah, okay. Except that it's not a canonical pointer, of course. It's an iterator. Yeah, that might be too confusing. It's kind of, I don't know. I'm not going to call an iterator a pointer. So then here the iterators turned into a pointer. Okay. Now I think I want to print a shader resource and see if it was added. The second time we come here. Which means that it is probably created. So say we come here and I see that it is created. I'm going to print it to see the result of our work. You say always shader resource was already created, and then we print shader resource, well, dereferenced, unknown type name. Well, did I not include a header? Or is it... No, I did. I forgot to add a descriptor in front of it. I think it prints the number of finished compiles. So now it's compiling and then it sticks at 0. Now we have the same error more often in different places. Descriptor. Stubbornly going to compile until all the errors are gone, instead of trying to fix them. No member named add descriptor set layout canonical ether binding. That's because it doesn't exist. I make the same error again. Add descriptor set layout canonical pointer binding. I don't think that exists. I just forgot to rename that back. It is called descriptor set layout binding, right? Also not highlighted. Thought this was it. Nope. Add set layout binding. Yeah, okay. That's what you get. Sometimes you use just set layout and sometimes you use descriptor set layout. It's too confusing. That compiled and it linked, and now I can run it, and now we can see those new debug output. That new debug output, which was I don't know. Let's just run it. Print it to a file. That's long enough, and then we look at the file. And I'm going to the top and search for always shader variables currently contained. That's not what I was looking for. I'm looking for an already exists. So this is not already. Created. This is our new debug output. So the second time we get into this function, which I wanted to fix today, it prints shader resource was already created, and then it prints what was already created. And of course I did not add printing our beautiful new vector. Oops. Yeah, so it prints the base, I think, but a bit fake. It's probably base colon colon, and then everything that follows is part of the base, isn't it? Until a certain point, probably this. This is all the base. And then follows image view handler and sampler handle and sampler handle, because it is a texture. But What I really need is fix base.h. It's getting a bit big then. No, where's this defined? Print on. Base, print on. You would expect a base.cxx here. Really? Oh, it's not defined at all. Right. They're talking about duplication. It was a virtual thing. Yeah. Pure virtual thing, even. Could have known it. Blah, blah. So, well, then we could look at uniform buffer, which only prints the descriptor set of the base. That's not going to work for me anymore. So instead I'm going to do base : and then I just print the whole base. How are we going to print the whole base? That is the question. How about descriptor set key is an accessor of shader resource base. Yeah. Just print the base. Well, it just looks a bit weird. Let's do this as a semi-cast. Okay, I have, yeah, this should work. But now I still have to define the print on of the base class base. It's a ridiculous name. Who calls their base classes base? It's because it's in the namespace. It's in the namespace shader resource. So then you get the shader resource base. Or really, you want to use the name shader resource. But then you get namespace shader resource : shader resource. And I didn't want it. Something is wrong here. Anyway, this works. I have to go to texture and do the same thing. What is it? Texture.cxx. Print on. Right, I think that works. So now to implement the base print on, let's just go to base h, and then it cannot be pure virtual anymore. So if now you call print on, it's going to, it is a virtual function, so it's going to print overridden print ons of the derived classes. But those in turn then call base colon print on, and that will call this function, but this time not as a virtual function. It's not going to use a virtual table. It's going to really call the implementation that I have here. So of course I probably should have called it differently. Not do this trick, because you never want to derive from this class and then not add a print on. That would be a mistake. But yeah, well, you know. Okay, I'm still thinking about it. It's kind of it works, but it's error prone in the sense that I do not want to allow anyone to accidentally derive from base without overriding print on, which means I need it to be pure virtual. In fact, I think you can give pure virtual functions also an implementation. Yeah, let's try that. So this would guarantee that you have to implement a print on in the derived class, but I'm still going to generate a print on for the base, even though it says equals 0. And we can still call that then. Of course, I could make up a new protected name for that, but it's not necessary, and this is kind of funny. I think it's the first time I do that. So I'm not sure if it works, but let's try this. It's even a new function. So pure virtual or not, I'm just going to implement it. And we are in a certain namespace. We are in a lot of namespaces. See the resource. Let's make that one thing. Oops. Okay. Now, okay, so just the usual thing. Not going to print mutex. It doesn't seem much make much sense. Created, I could print, I guess. And ambifix, no-ish. Could print the ambifix though. Then we get to see more details about what it is. Okay, let's print it as well. I'm going to print all of it. Yes, let's go back here. So these are the things that I want to print. So M created. Yeah, it's a race condition. Is it a race condition? Well, not from where I'm printing it, because we just checked that it was true. But in the case that it is, it doesn't really matter. I'm just going to use a memory order. Relaxed. Yeah. I probably should never even try to print this unless created is true. Although then again it's debug codes, so let's not think too long about it. And then I have m descriptor set key, which we can just print, I guess. Think so. In the ideal world, we can just print everything, no matter the type. Missing commas. Ambifix. Well, aren't you curious if this works? What can go wrong? Well, missing headers can go wrong, for one thing. And this set layout bindings container is defined in base. Okay, so we have that one. But we need a header to print vectors, and we need a header to print ambifixes, and God knows what all. Let's just see if it compiles or not. The standard bool alpha is maybe not really. Let's put this here. IO manip. Yeah, if I include debug.h, I can hardly imagine that IO manip is not already included. Undefined reference, so it did compile, didn't it? Undefined reference to suitable base print on. I think I just miss. Oops, configure, that would update something. And it did. Missing include at the top of really base.cxx. No, we cannot print something. What can we not print? Ambifix. Oh, that's funny. Yeah. Well, it was never meant to be printed. So this ambifix is an ambifix which cannot be printed. And I'm sure I printed it before. I guess I'm just calling object name on it. Seems the most logical thing to do. Let's call it object name. That worked. Okay, UBT, write it to a file. Hey, you get the other one suddenly. The race is still on. VI troop, and then we get ding doing. And it was already created, I think it was. Yep. Now we are printing a lot. Not really. Ends here. Okay, shared resource was already created. Base, now as a cost. Created, true, yes, otherwise we would not be printing it. Descriptor set key is 1, whatever. Set layout bindings, that's our new vector. And it has should have one element. Maybe we should print it as well. Size of a vector. Fortunately, this is an editor, so I can go to that. Brace. Yeah, so there's one element here. And then print object name is pipeline factory m sample texture. Now, don't you wish there were quotes around this? And then we have, wait, yeah, this belongs also to the name. Member, well, okay, texture Vort 3. It was mainly about this thing, right? So this texture has it's using binding 1 as it should for a texture. And it has a pointer, this pointer, which points to a set layout. And that set layout has sorted bindings. Binding 1 is a texture. And binding 0 is a uniform buffer. And it is using set index int 1. And we have a handle. So the exact same handle then, and of course the set index int, must be found in the corresponding uniform buffer. So I'm just highlighting this. And there we are. So for another shader resource, it says that is already created. and that is apparently the uniform buffer top position. Create is true. The script set key is 2, and set layout bindings is now containing set layout canonical pointer 2 sorted bindings. Binding 1 is now you get a repeat of the same thing. That's the combined image sampler, and then we have another one for the uniform buffer with the set index int and the handle, etc. And the reason is, of course, that this pointer is just the same thing. You can highlight that as well. So the pointer is the same thing, and therefore we might as well compare the pointer, because this is the canonical pointer. And the binding number is also given to be 1 for the texture and 0 for this uniform buffer. Object name here is different, is pipeline factory m top buffer, which is incorrect if you ask me. It's synchronous window in the top buffer. But well, this thing has 2 members apparently. Top position unused 1 and top position X. Loads of information. Okay. Yeah, and the other 2, they are in different. Well, they're alone in their own descriptor set. So they point each to something else. No, they don't. What is this? Object name? Oh, that's that's the window pointer or something, or pipeline factory pointer or whatever it is. I think it should be the window pointer, but it says pipeline factory here. It's still wrong. No, more importantly, it says that the canonical pointer must be different, which is nowhere to be found. What? I need my cursor. There is no pointer here. Oh, here's the pointer. Finally. Yeah. So this thing here should be different from the one used here, and it is. This ends on 88 and that one ends on 60. Okay, they still use the same handle though, because the handle here, that's the layout handle, because the layout is the same. Right. Well, this looks this very, very limited test application. It's all I can check for now. And it looks that all the information is there. I need to make a larger test application. Test more things. Then I want to go back to that function. Let's pipeline. That sits in pipeline factory, I think. No, it doesn't. I don't know where anymore it is. Oh wait, it's shader input data, I think. Yep, is it? I think so. Yep, this is the function that I want to fix. Although in half an hour I'm just going to stop the stream to eat. My stomach is hurting again. It's not, something is wrong. So what we just saw was basically this. Well, no, it was not UU and TT. It was a UT and a U and a U. But basically what we saw was this. And then another one with that. And these two things are stored as pointers and they were the same. And the binding number was different. So far so good, and it's also a vector, so if another one is created with different with a different descriptor set, then that should be added to that handle. For example, if we created this one, and then later the textures are swapped. Which one was swapped? 0, binding 0 for U2. So yeah, the textures are swapped here. So we are going to create another descriptor set for the textures here, because the binding numbers are swapped. And then we end up with this block here. So then we have a vector with two of them in it. The same pointer here and another pointer here, which is the same here for these two. Right. I think I'm literally going to compare the pointers, because I really don't know why that would not work. Should work. Meaning that I'm not really interested in the contents anymore of this, except when I am. But when I want to know if they are equal, that is compare the pointers, and then I need a pointer, not a reference. So what does the accessor return for this pointer? That is an accessor in our new set layer binding object, which I'm adding here. Well, not really. I'm just passing it by two parameters. I'm passing a pointer here, and I want to be able to retrieve that exact pointer. Can't find pattern. Let's run ctex again. Quit, make ctex. Yes, so it is set layer binding here. It's being constructed from a pointer. The pointer is stored and the accessor returns the pointer. Okay, I can just see a pointer here. That's good. Canonical pointer, right? Does it say that it is canonical? It says it even that it is canonical. Okay. Now to find when I do not have to create. When do I not have to create a new descriptor set? I'm getting tired, even though I said I would do a marathon until it works. Feeling tempted to quit for today. Well, for a while. For the first time today, I'm reading the chat. Probably missed a lot. So yeah, this code plus says why canonical pointer used in pipeline. Well, I'm having a cache in the logical device, so that's kind of a singleton almost, assuming we have just only one graphical card. We also have, well, we have one. My applications are going to have just one logical device, so it is. And then putting a cache inside of that means that every object that is unique is added to it. But if I try to make another object that is with the same create info, I'm just going to use whatever is in the cache. So we do not have duplicates, and that means that I might as well use pointers to those objects that point to those objects in the cache, because each object of a certain kind with a certain layout only appears once. You can almost, well, you just literally can actually use the pointer value as the ID for that layout, without even looking at the layout anymore, if you understand what I mean. Plus, the reason that I started to use the pointer in the first place was because I needed something to point to something with a long lifetime. Otherwise I would have to make copies of it anyway. So say you have a few large-ish objects and you want to create them only when they are different. I store all the large objects in a cache. When I want to create a new object, I look if it was already created by looking it up in the cache. If it does not exist, I create it and I add it to the cache. If it does exist, I do not add it to the cache, but I just return a pointer to that cache. And the cache is built such that those objects are never moved. So then that pointer is a canonical pointer. It is the only pointer that points to objects of that type. The pointer will always be valid, never be invalidated. And I might as well use the value of the pointer itself anywhere in the program to see if the objects are equal or not. Because if they are equal, they must be the same pointer. Because there are no two objects in the cache that are equal, but not the same object. So that was the idea here. So Josh asked, what are you working through? That question to me. Today I wanted to finally finish this this function here, because I've literally been procrastinating, not wanting to program even, because this function was scaring me, and well, it's still scaring me actually. And I don't want to be, well, lay awake at night anymore thinking about this function. I just want it to be finished. It has to be done. So using this as a model, the idea is now that upon encountering a shader resource that does not already exist, or does not matter, I'm just creating it when it doesn't exist. No, what I want is figure out if I can use an existing descriptor set handle for the current setup. And the only way to find out is by iterate over all the shader resources that I have, and then find if all the shader resources with the same set index hint all have the same pointer and the correct binding. Let's first look if they have the same pointer. And then I mean all of them. And I need to do that per set index hint. So I'm going to loop over all the shader resources. I'm just going to make this a slow code because I'm so sick of it. It's never going to be slow anyway. Going to use a map for the indexes, so I can create a map while going. Let me see. I want to run over all the shader resources, I think. So that is this loop here. Yeah, little toxic pain. Do I hear your daddy talking? Ah, sorry, I shouldn't have said that. What a name. I'm writing a Vulkan engine, but if you know what Vulkan is, then I can get into more details. If you do not even know what Vulkan is, then I guess it doesn't make much sense to get more details. I don't know. Well, where is it? Code plus. Coding XM. I don't know. I'm willing to look at it if you have an URL to a certain problem. I'm going to have to run over it at this point. And then for each of them, I'm going to need I'm going to need the set index hint that the factory wants us to use. Well, it's amazing any game. So are you into 3D programming? Do you code in C++? Any game? I mean, at the very least, if you say that you understand a lot, I would assume that you know what is a uniform buffer, and for example. Or maybe you just understand the abstraction that I typed there in the comments. So I have this already here. I can just use the set index hints without converting them to the real set index at this point. Let's go. I'm going to copy this anyway to the new for loop. Oh, well, maybe I just got confused by you using the word everything. I think you meant I can't understand almost anything. In which case, just forget what I said. I read it as I almost understand everything. So I have a set index hint now, and then what to do? I want to combine all the set index hints that are the same. Maybe I should use a vector. Set index hints are always small. Set index hint. Combine those things and then store the pointer to it. Oh, that's it. Yeah. It's finally lunchtime. So what I want to detect, I guess, is that if there was another shader resource with the same set index hint, but a different set layout pointer, or not the same set layout pointer, rather, anywhere, yeah, that's it. Then we need to create one. Ta-da! I think I see the light here. like a lot more than before. I'm not even going to click this away. I really have to eat very quickly now. So yeah, yes it is. I'm going to eat. Okay, I'm just going to eat. Anyway, I'm really I just understood something that is a big step, I think, in solving this. Of course, it did help that I finally have all the information ready. So now it's just a matter of writing this code. And I'll be writing it when I get back. When I said I was going to do a marathon, I was also thinking about even keeping streaming while I eat. So like I'll be back in half an hour and then keep streaming, but nah, let's not do that. Plus my stomach is playing up, so maybe I should take a longer break. I'll be back later.